Welcome to Section 2, Lesson 3. In the previous lesson, we learned how to combine like terms and distribute a single factor across a single set of parentheses. Today, we extend that workflow to expressions with multiple layers of grouping. These nested expressions look intimidating at first, but the workflow is exactly the same as before, applied one layer at a time. The key habit you build today is the discipline of always working from the innermost grouping outward, never the other way around. Nested expressions show up everywhere in algebra and beyond. Function composition uses them, recursive formulas use them, calculus chains rules use them. So building the innermost out reflex now will pay off across every later course you take in mathematics, computer science, physics, or engineering. The simplification work is fundamentally a bookkeeping exercise, and the bookkeeping is exactly the routine we practice in this lesson. First idea on the board. Nested expressions have parentheses inside parentheses, sometimes 2 layers, sometimes 3 or 4 layers deep. The notation often switches between round parentheses, square brackets, and curly braces to make the layering visually easier to track, although mathematically all three are interchangeable as grouping symbols. Read the expression carefully and identify each layer before you start simplifying. Second idea. The single most important rule for nested expressions is always simplify the innermost grouping first, then work outward one layer at a time. Going outermost first is the classic beginner mistake and almost always produces a wrong answer or a partial simplification that gets stuck. Innermost first follows directly from PEMDAS, where parentheses always have priority over the operations outside them. Building the innermost first instinct early in algebra prevents an enormous amount of confusion later, especially when expressions grow to 4 or 5 layers of nesting in topics like polynomial factoring and rational expressions. Third idea. Watch the sign on every distribution as you work outward. When the factor outside a layer is negative, the negative sign distributes to every term inside, the same way it did in the simpler examples from Lesson 2. The sign distribution mistake is by far the most common error in nested expression work, and it usually shows up at the outer layers where students get tired and forget to check carefully. The discipline to check every sign on every distribution, especially the outer ones, is what separates an A on a homework set from a B. Build the habit early, and it will save you many points across the rest of Section 2 and the algebra course as a whole. Take the expression 2 times the bracket containing 3 plus 4 times the quantity x minus 1. The square brackets contain a sum that itself contains a parenthesized chunk multiplied by 4. So we have 2 layers of grouping, with the inner layer being 4 times the quantity x minus 1 and the outer layer being the entire square bracket. Notation often uses brackets for outer and parentheses for inner, just so you can read the layers visually. Here is the rule that drives every nested simplification. Always simplify the innermost grouping first. Once the innermost is reduced to a sum of simple terms, treat it as one chunk and move outward to the next layer. Repeat the procedure layer by layer until no parentheses or brackets remain anywhere in the expression. The work flows from inside out, never outside in. Step 1 in our example. Distribute the factor 4 across the innermost grouping, the quantity x minus 1. 4 times x minus 1 becomes 4x minus 4. The innermost parentheses are now gone, replaced by a sum of 2 simple terms. The expression overall now reads 2 times the bracket containing 3 plus 4x minus 4, with only the outer bracket layer remaining. Step 2. Substitute the simplified inner result back into the outer bracket and combine like terms inside the bracket. The bracket now contains 3 plus 4x minus 4. The constants 3 and minus 4 are like terms, and they combine cleanly together to give -1. So the bracket simplifies to 4x minus 1, and the expression becomes 2 times the bracket containing 4x minus 1. Step 3. Distribute the outer factor across the simplified bracket. 2 times 4x equals 8x. 2 times negative 1 equals negative 2. So the entire expression simplifies to 8x minus 2 with no parentheses or brackets remaining anywhere. The original two-layer expression has collapsed all the way down to a clean two-term simplified form. An important variation: when the outer factor is negative, the negative sign distributes to every term inside the bracket the same way the previous lesson taught for single-layer distribution. So negative 2 times the bracket containing 4x minus 1 equals negative 8x plus 2, with both signs flipped from the positive case. This sign distribution at the outer layer is the place where most students slip up, so always pause and double check the sign on every term after distributing a negative outer factor. Doing this check after every distribution layer takes only a few seconds and prevents the most common single error in nested expression work, an error that has cost students countless homework and test points across decades of algebra teaching. Here is the first worked example. Simplify the expression 2 times the bracket containing 3 plus 4 times the quantity x minus 1. The expression has two layers of grouping, with the inner being 4 times x minus 1 and the outer being the bracket. Innermost first as always. Step 1. Distribute the inner factor 4 across the inner parentheses. 4 times the quantity x minus 1 becomes 4x minus 4. The inner parentheses are now gone. We do not yet do anything with the outer bracket. We treat the inner result as one chunk and move on. Step 2. Substitute the inner result back into the outer bracket. The expression now reads 2 times the bracket containing 3 plus 4x minus 4. The outer bracket is still there because we have not distributed the outer 2 yet, but the inner parentheses are gone. Step 3. Combine the like terms inside the bracket before distributing the outer factor. The constants 3 and negative 4 are like terms, and they combine to give negative 1, so the bracket simplifies to 4x minus 1. The expression now reads 2 times the bracket containing 4x minus 1. The combine step here is essential because it reduces the bracket to its simplest possible internal form before we apply the outer distribution, which avoids extra terms appearing later that would have to be combined a second time. Step 4. Distribute the outer factor 2 across the simplified bracket. 2 times 4x equals 8x. 2 times negative 1 equals negative 2. So the entire expression simplifies to 8x minus 2. Notice how the workflow always goes innermost first, then combine inside the next layer out, then distribute the next outer factor. So the answer is 8x minus 2. The big lesson from this example is the strict innermost out workflow, with combining like terms allowed at every layer once the inner parentheses are gone. Skipping a layer or going outermost first nearly always introduces an arithmetic error. Stick to the rhythm: distribute inner, combine, distribute outer, combine, and so on until no grouping remains. Two-layer expressions like this one are the most common form of nested expression in early algebra and in word problems, so practicing this exact pattern repeatedly until it becomes a reflex is one of the most efficient uses of homework time at this stage of the course. Here is the second worked example. Simplify negative 3 times the brace containing 2 minus the bracket containing x plus 2 times the quantity x minus 1. 3 layers of grouping in this one: the innermost parentheses around x minus 1, the middle bracket containing the sum, and the outer brace. The outer factor is negative 3, so we will need to be careful with sign distribution at the outer layer. Step 1. Distribute the innermost factor 2 across the innermost parentheses. 2 times the quantity x minus 1 becomes 2x minus 2. The innermost parentheses are now completely gone. The whole expression reduces to negative 3 times the brace containing 2 minus the bracket containing x plus 2x minus 2. Step 2. Combine the like terms inside the bracket layer. The 2x terms x and 2x combine to 3x, and the constant negative 2 stays. So the bracket simplifies to 3x minus 2. The expression now reads -3 times the brace containing 2 minus the bracket containing 3x minus 2. We have made one layer of progress and now move to the next layer outward. Step 3. Distribute the minus sign across the bracket. The minus in front of the bracket flips the sign of every term inside, so minus the bracket containing 3x minus 2 becomes minus 3x plus 2. Then combine the constants 2 plus 2 equals 4. The brace now contains the simpler expression 4 minus 3x. The minus distribution at this layer is exactly the kind of sign flip step where students lose points. Doing it carefully here pays off. Step 4. Distribute the outer factor -3 across the brace. -3 times 4 equals -12. -3 times -3x equals positive 9x, because two negatives multiply to a positive. So the entire expression simplifies cleanly to -12 plus 9x, which we reorder by descending degree to give the cleaner form 9x minus 12. So the final answer is 9x minus 12. The big lesson from this three-layer example is that the same innermost out workflow handles any number of nesting layers without change. Each layer requires one distribute step plus one combine step before moving to the next layer outward. The negative outer factor in the last step is also a reminder to double. Check signs whenever you distribute a negative across a sum or difference. 3-layer and 4-layer nested expressions show up regularly in calculus, especially when the chain rule is applied to compositions of 3 or more functions. So the discipline you practice on 3-layer algebra expressions transfers directly to harder material in later courses. Each additional layer adds a small amount of bookkeeping, but no genuinely new technique. 3 mistakes that catch every algebra student during their first weeks of nested expression work. Each one is fixable by slowing down and following the strict innermost out workflow. First mistake, trying to distribute the outermost factor before simplifying the inner layer. A student looks at 2 times the bracket and immediately distributes the 2 across whatever they see inside, even though the inner expression still has its own parenthesized chunk that has not been simplified. This produces a partial mess that almost always leads to a wrong answer. Always simplify the innermost grouping first, only then move outward. Second mistake, forgetting that a negative outer factor flips the sign on every term inside. A student writes -2 times the bracket containing 4x minus 1 equals -8x minus 2, distributing the negative only to the first term. The correct simplification is -8x plus 2 because the negative reaches both terms inside. The two negatives in the second product, -2 times -1, multiply to a positive 2. Third mistake, skipping a layer of grouping entirely because the student loses track of how deep the nesting goes. A student simplifies one layer and then writes the answer, forgetting that there was an outer layer left to process. Always count the layers before starting and check that you processed all of them before declaring the simplification finished. Every layer needs a distribute step or a combine step before you move on. Nested grouping is not unique to algebra. Anytime one operation must complete before the next can start, the system uses nested grouping notation, and the simplification is always innermost first. 4 real-world examples below. In code, every programming language uses nested parentheses, brackets, and braces to group statements, function arguments, and array indices. The compiler evaluates innermost groups first, exactly the way we did in the worked examples. Reading nested code requires the same skill as reading nested algebra. Identify the layers, simplify innermost out. In finance, an escrow calculation might compute the net payout as the principal minus a bracketed bundle of fees, where the bundle itself contains the sum of a tax line and a commission line in nested parentheses. The accountant simplifies innermost first, exactly as the algebra workflow prescribes, to arrive at the final amount that hits the seller's account. Recursive function notation in math, like f of g of h of x, is exactly nested grouping. To evaluate the composition, you compute h of x first, then g of the result, then f of that. The innermost first evaluation rule from this lesson is the same rule that drives every recursive function evaluation in calculus, computer science, and applied math. In optics and signal processing, a measurement pipeline often runs through a sensor first, then an amplifier, then a filter. The signal flow looks like filter applied to amplifier, applied to sensor, applied to input. The innermost stage runs first because each later stage depends on the output of the earlier ones. The mathematical formula that describes the pipeline mirrors that nested structure exactly. 3 things to take with you from this lesson. Nested expressions look intimidating, but the workflow is simple, and the same rules from lesson 2 carry over directly to every layer. First, always simplify the innermost grouping first, then work outward layer by layer. Going outermost first is the classic beginner mistake and produces wrong answers nearly every time. Innermost first respects PEMDAS and ensures that the inner result is a clean, simplified chunk before the next layer touches it. Second, distribute the relevant factor and combine the like terms at every layer before moving to the next layer outward. Each layer typically requires 1 distribute step plus 1 combine step. Skipping either step in any layer leaves the expression partially simplified and usually produces an incorrect final answer. Third, when the outer factor is negative, the negative sign distributes to every term inside the layer. This is the single most common error in nested expression work, so always pause and double. Check the sign on every distributed term after a negative factor crosses a layer. The check costs only a few seconds per term and saves entire problems from being marked wrong because of a single missed sign flip. Make this check a permanent part of your workflow when distributing across nested layers. Coming up next, the lesson called Evaluating Expressions, where we substitute specific numerical values for the variables and compute the resulting number using PEMDAS together with the nested grouping skills we built today. The substitution adds 1 new step at the start of the workflow and otherwise leaves the simplification machinery exactly the same. Evaluation is also where the patient discipline you built on nested simplification really pays off, because evaluating a wrong simplified form will produce a wrong number even on a perfectly executed substitution.